This is going to be, I hope, another interesting project. We will again work with images, since I really think that they are a really good way to practice working with matrices in an interesting, non-boring way. We will switch gears a bit now, and this time we will work on a colorful image, and I will also briefly touch on 6-dimensional matrices. Now, just like with our previous project, we will create our own colorful image, but what is a colorful image in terms of a matrix? We saw the grayscale image, values from 0 to 255 in a 2-dimensional matrix. A colorful image is a 3-dimensional matrix. In this specific case, the 3-dimensional matrix of the image is 3 2-dimensional matrices stacked. Or imagine it like 3 floors of a building, one for each of the colors, one for red, one for green, and one for blue, the RGB. Each of these colors, like the grayscale image, is represented by a value between 0 and 255, which simply represents its brightness. Let's visualize it. So we have a vector. The vector is 1-dimensional. We have some values in the vector. Then we have a matrix. The matrix is multiple vectors. This is now a 2-dimensional matrix. Now, if we add multiple 2-dimensional matrices, we will get a 3-dimensional matrix. So we can have the following thing. I'm going to draw it like this. So this is our first 2-dimensional matrix, red. Then we have the green one, which will be on top of that matrix. So we will have another matrix. So actually this is like that, on top of it, like this. This matrix will have its own rows and columns, like this. And finally on top we will have the blue one, which is something like this. I'm not very good at drawing, but I hope that you get the idea. And all of these matrices actually create a cube. If the number of columns, rows, and the height, the number of these matrices are equal, you will actually get a cube. So here we have 3 floors. Each of the floors is one single matrix. Now, let's create our 3-dimensional matrix, a random matrix. So image equals to rand I from 0 to 255, and we have to give it 3 dimensions. So again, it will be 500 by 500 by 3. The 3 simply means that we will have 3 floors of matrices, 3 2-dimensional matrices. And we can visualize it. Let's convert it to unsigned integer. So uint of 8 of image and visualize it. So figure im show of image. Let's run it. Oops, I forgot to suppress the output, but as you can clearly see, let's zoom in. As you can see, we have colorful pixels, a huge variety of different colors. We have green, blue, yellow, any color that you can imagine. And as you can see down here, it says image is a 500 by 500 by 3 unsigned integer matrix. This is what a 3-dimensional matrix looks like, and this is what a colorful image in MATLAB is in general. And this is what a colorful image in general is. Now, if we want, we can remove one of these colors or 2 of the colors. For example, we may leave it with red and green only. To do this, we must set all values of the blue color equal to 0. I said that it's RGB, so the third matrix is the blue color. And if we say image, all rows, all columns of the third matrix equal to 0, and we visualize it after that, we will get colors without blue. So this is only red and green. As you can see, we have no nuances of the blue color. Notice that we are not deleting them, we are simply setting them equal to 0. Similarly, we can set the green equal to 0, and we will end up with only a red image. As you can see, different nuances of red. We have dark red, we have light red, we have black, and we have full brightness red. But it's only red. We removed the green color, and we removed the blue color. Now here I'm going to show you something interesting. Instead of listing all of the matrices that you want to set equal to 0, we can simply say 2 and 3. We can give it a vector, and this will set the second and the third matrix equal to 0. There we have it, again a red image. If I set 1 and 3, we are setting the red and the blue to 0, so we will get only green. There we have it, only green. And we can do the same thing with only blue. So there is another way in which you can do this, and you can simply say 1, 2, 3. You're generating a vector with an increment of 2 between 1 and 3. Now in this specific example, it's probably, first let me show you, it works the same way. We get only the green color, so the first and the third matrices are 0. This approach is probably not the best approach for this specific example, and probably just saying 1 and 3 equal to 0 is much more readable. If you have some bigger matrix and instead of writing 1, 3, 5, 7, 9, 11 up to 1000, so 1000 indices, you can simply create an inline vector within the selection, and you can say 1, skip every second dimension up to 1000 and set them all equal to 0. Now let's move it back to 1 and 3. Now what does a 4, 5 and 6 dimensional matrix look like? Well, now let's imagine first that we have a 3-dimensional matrix. It's still a matrix, it just has more dimensions. A 3-dimensional matrix that has equal amount of rows, columns and floors, which, as I said earlier, is simply a cube. Something like this. Something like this. Yep, I'm not very good at drawing, but this is what it will look like. And we have, it's separated in columns and rows. So we have tiny little cells inside this cube for each of the values. What is a 4-dimensional matrix? A 4-dimensional matrix is a vector of 3-dimensional matrices. So a 4-dimensional matrix is simply a matrix that has multiple cubes. So we have another cube here, and we have another cube here, like this, and we can have many more cubes in the line. So this will be a 4-dimensional matrix. Each of these cubes is a 3-dimensional matrix, but when you put them together you get 4 dimensions. What is a 5-dimensional matrix? Well, a 5-dimensional matrix is a matrix of cubes. So you get cubes not only in a single row or column, you get them in rows and columns. You get them in a matrix, so you get another cube up here. I'm going to draw them as squares or not. You get another cube here, and you get another one here. This is now a 5-dimensional matrix. A 6-dimensional matrix is when you add another dimension. You have a 6-dimensional matrix is a cube of cubes. So you have more cubes here behind the cubes. So more floors. Imagine it whatever you want. And using this approach, you can actually create 7, 8, 9, 10, 20 dimensions, as many as you need. So it's not some new way to see the world. We know that we perceive the world in 3 dimensions. It's simply a way of representing complex data. Now, with this out of the way, we will proceed with the next part of our project.